Hello everyone! In this video we will talk about the double exponential smoothing, which is a step further compared to the simple exponential smoothing that we have talked last video. A quick reminder for the simple exponential smoothing: you have this alpha parameter and the formula is like this. You have the forecast equal with alpha multiplied by the last demand plus 1 minus alpha multiplied by the last forecast. Okay, now we add also the trend. If the simple exponential smoothing was taking into account only the level, which means the average value of the demand, now the double exponential smoothing is taking into account also the trend. The trend is the difference between the demand and the previous demand. So the formula is like this. The forecast is the sum of the previous level and trend, while the formula for the level is like this. The level is alpha multiplied by the demand plus 1 minus alpha multiplied by the sum of the previous level and trend. And the formula for the trend is like this, is beta, okay, multiplied by the difference between the current level and the previous level plus 1 minus beta multiplied by the previous trend. So this is a step further. However, this has some limitations because the model assumed that the trend will go on forever, which is a problem for mid and long-term forecast. We will solve this with a damped forecast, which we will see in a second. What I want to show you is how to optimize these parameters in order to minimize the mean absolute error. We will use solver like in the simple exponential smoothing. We have already the parameters filled, so the objective is to minimize the mean absolute error, okay, J4, by changing variable cells alpha and beta, okay, with the constraints alpha and beta to be between 0 and 1. We have already all the parameters, and we will use the evolutionary algorithm. We press solve, and Excel has found a solution. So you see the mean absolute error was minimized to 14.4 with an alpha of 99.9 and a beta of 57. So this is how we optimize the model. And now let's see the damped double exponential smoothing. What's the idea? Due to the problem that I have mentioned before, that the trend will go on forever, we apply a third parameter, phi, that will decrease gradually the trend. Okay, so what we add to the formula, first of all, in the forecast formula, we apply the phi parameter to the trend, to B. Okay, so the formula is the level, previous level, plus the trend multiplied by phi. And also in the formulas of the level and trend, we apply the phi parameter to the trend. and we we will compare with the simple with the double exponential smoothing without the damped parameter. Let's put the same value for the alpha and beta parameters. Okay, so now we see the trend of the forecast, and here with the phi parameter we see that while the forecast was going up, so it was going up indefinitely, now it is decreased. It is decreased, and at some level it remains constant, because you see the trend is diminished until it gets to zero. Okay, so after we finish the real periods, we remain with the formula of the forecast being the previous level plus the trend multiplied by phi. But at some point the trend becomes zero, so the forecast remain constant. So this is a more real estimation for the long term. One thing I want to show you before we finish this video, in Excel, in the data analysis tool pack, we have the exponential smoothing tool, but this is only for the simple exponential smoothing. We will make an exercise here, and we will compare with our simple exponential smoothing that we made with the formulas. So we have to tell Excel the input range, which has labels. Okay. The damping factor here is the 1 minus alpha, so we will put 0.3 in order to have an alpha of 70%. Okay, and the output range will be here. Okay, we check a chart output and press OK. Okay, so you see that Excel made the same forecast that we did in the previous video in the simple exponential smoothing, and the chart also looked the same with a small difference in formatting. So thank you for watching this video.